Hello, my friends. Today we are solving some root equations, which are also sometimes called radicals. If you look at all these equations, we got square roots, we got cube roots or third roots, we got fourth roots, fifth roots. You can keep going on whatever you want. As you've learned from me in this chapter, you just keep undoing. We've actually already solved some things where we used roots. They weren't in the equation already, but if we had like x to the third, we would take the third root. If we had x to the fourth, we would take the fourth root. Today, if we have the fourth root, we're just going to raise it up to the fourth power. So undo. I love starting off with number 1 here because it looks like a fourth root, but that's really 4 times. So remember, our goal is to just undo and get those x's by themselves, or really get the group by themselves is what you're trying to do. So we divide out that 4. We are not doing the problem, we are undoing the problem. 8 divided by 4 is 2. Cool, at this point we want to undo the square root, so we're going to go ahead and square. Does it change the x and the 10? No, because it just undoes the square root. So square and square root cancel out. It actually will square the number over on the right, but we just bring down our x plus 10. 2 squared is now 4, and we got easy peasy middle school math to solve. Always a good idea to plug your answer back in, especially if you get a negative, because you know you can't take the square root of a negative. But if we do plug a negative back in, we do the group first, and that's negative 6 plus 10. That's a 4. You can take the square root of 4, so we're good doing the rest of that problem. But again, not a bad idea to go ahead and double check your work, double check your answers. We take a look at number 2, and we have a square root here. It's got a 3 out front. It's very clear. It's a plus 3. We're going to go ahead and undo that, subtract 3. Remember, we're trying to get the group by itself or the root by itself on all these problems. We have the square root of 8x, and that is equal to a negative 2. Now, if you think at this moment, you can save yourself some time, because when you take the square root, remember, you can't take the square root of a negative. So whenever you take the square root of a positive, you should end up with a positive. So there's going to be no possible way to take the square root and end up with a negative. It's like the absolute value. You can't take the absolute value and end up with a negative. So I can write no solution right now, but I'm going to pretend that I don't know that. Right? Pretend I don't know that. How do we get rid of the square root? We go ahead and square, and we square. And look, the algebra works out. Square and square root cancel out. We get 8x. Negative 2, when you square it, turns to a positive number. It looks like we can keep doing our math here, right? And we go ahead and we divide by 8 on both sides, and we get x equals 0.5 or 1/2. But if you're smart, you should always go back and plug your answers in and think about what happens when you plug your answer in. Cool. We plug in 0.5 for x there, and 8 times 0.5 is 4. The square root of 4, we can do that. That's 2. But now we have 3 plus 2, which is 5. That is not 1. So we can see that it's kind of like an extraneous solution. So we have no solution. Again, we can decide this earlier on, and we can realize this earlier on if we pay attention to when we get that group by itself, when we get that square root by itself. If it is equal to a negative, we get to stop right at that moment and write no solution. So we could have done that a little bit earlier, writing no solution up there. Cool, I'm going to go ahead and slide this up a little bit. Actually, I'm going to leave it because number 1 and number 3 I made similar. So if you take a look at number 1 and number 3, one of them is the fourth root. That's what we're working on now on number 3. But up above, it was 4 times a square root. This is a fourth root. We can get rid of a fourth root by doing a fourth power. All right, so on the left side, those are going to go ahead and cancel out. We're going to go ahead and bring down our x plus 10. And then 8 to the fourth power, 8 times 8 times 8 times 8. I got to type that in. 4,096. Cool, after that, it's just easy. We go ahead and we subtract our 10. And we've got our final answer of x equals 4,086. We're welcome to go ahead and plug that back in. But when we have a fourth root, that's the same as like a square root. So whenever we have those even numbers, those even roots, that little even exponent, we got to make sure that those are always equal to a positive number, and then it will be possible. If it's equal to a negative, that will be a no solution. Cool, we'll head on over to number 4, and we have a third root here. We're going to undo, and then we're going to start thinking when we just get down to that root or to that group. So we go ahead and we subtract 5 on both sides. Undo, undo, undo. We got the third root of 8x equal to a negative 4. And you might have noticed I made it similar to the problem above it. Above it was a 3 plus. In this case, it was the third root. Now we have a third root equal to a negative. That wasn't possible with a square root because square roots or even numbers will pair up. But for a third root, it is possible. We could have negative times negative could equal a negative. So this is going to be possible, but it's always not a bad idea to go ahead and plug your answer back in when you're done and see how the math works out. I can go ahead and get rid of a third root by doing the third power. And that will just cancel out and give me 8x over there. Negative 4 times negative 4 times negative 4. 4 to the third power is a negative 64. And then we go ahead and divide that by 8 to finish up our problem. And we get an x equals negative 8. Again, whenever you get a negative, not a bad idea to go ahead and plug it back in. So if I do plug it back in the square root, I have 8 times negative 8, which is negative 64. I go and take the third root or the cube root of negative 64, and it does work. It gives me negative 4. Negative 4, I add the 5 back in, and I get that 1 that's sitting there over on the other side. So it is possible whenever we have odd roots to have a negative, right? But up above, we notice we would have a no solution because we had a square root. A square root is an even exponent squared 2. That would make that one not possible up above. Cool, we'll slide on to our last example. I'll leave those two there for us to take a peek at if we need to. I'm going to go ahead and move on. Here we got a 6th root. I'm thinking right off the bat, 6th is even. They got to pair up and be positive. So if I get a negative, it's going to be no solution at that moment. Okay, we go ahead and do some math. We subtract 5, we subtract 5. We are undoing, we are undoing, we are undoing. We got the 6th root of x minus 1 equal to, here we go. We got our negative. At this moment, we get to write no solution. It's not possible if I had 6 things to end up with negatives because these two are going to pair, be positive. Those two are going to pair, be positive. Those two are going to pair and be positive, right? So it's not possible, but watch. It's kind of like an extraneous solution. If you keep doing the math, you can go to the 6th power. You can go to the 6th power, and that gives us x minus 1 equal to, what is negative 2 to the 6th power? That turns to a positive 64. Then we go ahead with our last step, and we add 1, and we add 1, and those cancel out. And again, x equals 65. So I do math, and I get an answer, and it's always smart to plug things in this chapter. I'm going to go back and plug it in. If I plug in 65 minus 1, that gives me 64. I am now going to find the 6th root of 64, and that is just a 2. And if I take a 2 and I add it to, what was that? A 5. 2 plus 5, that's clearly a 7. That is not a 3. That's like an extraneous solution. It's a no solution. We should have written no solution earlier. At the moment that we saw we had an even root equal to a negative, not possible, no solution. Hopefully that helped you out.